All right, so let's get started again. The next part was we were actually going to look at an actual example. So we've looked at some of the data structures and at least some of the important data structures, and we talked about, why we're using, let's say, a slut map and what's the purpose of that and how it's, you can say, what kind of abstractions are we using, etc., and why. Correct. Then we came down to a point that we wanted to say, let's actually look at an actual example of how I've implemented Pliron Cliff. By the way, I forgot to mention one thing. Do you guys know what Pliron stands for? Pliron is not just a name.
He mentioned in that why Pliron.
Nobody read it. Huh?
No, I read it. He has interpreted.
Everybody knows it's written out over there. What is it? He did not even read it. I'm pretty sure of that. You're sleeping. You?
What?
Don't ask me.
I only saw a video. I was understanding a video.
Give me courage. Give me courage. Anyway. So, I wanted to go see this.
Programming language intermediate presentation.
Oh, right. Very phone bro गए थे.
You don't listen to video also. I
Can you
remember.
connect your phone?
It's there.
Because it should make sense. You might be wondering why is it called Pliron?
I know you told listen to video.
Sir, you commented on the video.
He will do that. Why not?
It's an agreement actually.
There only and programming language intermediate.
Yeah.
Okay. All right. It's called Programming Languages Intermediate Representation. It should be fairly straightforward. That's why it's called Pliron. All right. Anyway, now let's go back to our Visual Studio Code. So I wanted to show you an example where we take this simple add function. All right, which is basically this is what Cranelift IR is. This is what it looks like. Okay, and we want to convert that to Pliron.
One question. How easy is it to get Cranelift IR if I just write a Rust code?
Yeah, that's not too far. Like for example, I don't have it here.
We can just run cargo, emit, something like that.
Yeah.
Okay.
I'll show you. So let me go here, do another GitHub thing, and come here and is that dude? You want to go to
Cranelift IR.
Yeah. So I have a test thing. I just captured everything over here just to be clear.
Okay.
So if I go ahead and write this, I can basically run it with this. The code generator already exists. So directly I can produce. It's written LLVM-IR over here, but it actually needs to be Cliff IR. But since they did not change it, it's still showing as LLVM-IR, but just so that you know. So if I take this program, which is written in Rust, it gets converted to all this stuff. And this is what I was going to talk to you about.
Cliff IR you wrote, right? Cliff IR. You wrote a Cliff IR, right?
No, that is example Cliff IR. If you were to do something with actual, Rust code, if I wrote this Rust program, it will get compiled down to something like this. There's a lot more. All this stuff is comments, all the semicolon stuff.
Okay.
And this stuff is just basically talking about the target and stuff. So, and all these are compiler options that are enabled.
Okay.
So the comments we'll get to. And then you'll have global values, which are not there in my example. I have to add support for that and all. And then you have blocks. And then these are not actually present. These are not really there. They're just, so they're saying that V2 means V0, V5 means V0. They're just sort of naming it. This is an Cranelift instruction. and then this is a Cranelift instruction. And then you have a block 1. So block 0 with 2 block parameters, block 1, then
No parameter.
with no parameters, and then you have 1 instruction here. Sorry, 2 instructions here. And then it can either branch to block 2 or block 4. This is all CliffIR.
Okay.
You can generate it by your,
Simple.
like basically going through the Rust pipeline, you can do it. This is all available to you, so you don't need to worry about it. So this is a little more complicated, so having to deal with this is a bit more, what you'd say, work. So what I've done is I've taken a simple thing. I've taken this, and there's a pre-ready-made function available to you that you can call to parse any Cliff code into CliffIR.
Okay.
Into basically, parse any CliffIR into an actual function. This function is not Pliron function. This function is a Cranelift function.
Okay.
So if you see this, if I click on this, you see where we went to?
Cranelift one.
Get it? So the first thing I do is I take the IR, I'm parsing it. I'm basically creating in-memory data structures to hold that function. But that's not Pliron, that's Cranelift. So first I need to have something in memory in Cranelift form. Then I use that to convert to Pliron Cliff. Get it?
Okay.
Yeah.
So first I have this. Then slowly I start cycling through all the functions. Here I only have one function, so there's no too many functions. So for func in functions, this is a vector of functions. So for func in functions, first I create something called a conversion store. I'll tell you what that is. Then I create my context. What is my context? This is the Pliron context.
That's all types.
Okay. Then I'm going to register the dialects that I need. I need a built-in dialect. Built-in is already provided. So if you actually see here, if I go to source, built-in is already there. Apart from LLVM, Pliron LLVM, the author has also provided a built-in, it's like standard library. Okay. Some ops, some types, some straights, that will always be there, is available to you. Okay. So that is,
This can be used for that also, everything.
yeah. So I register my built-in thing, then I register my dialect. Crate is basically my crate, Pliron Cliff crate. I register that dialect, then I basically call a function called convert function. And I pass the function, the context and the store. So let me come to the conversion store first. What is the store? Let me just go up. This is the store. The store is nothing but for each Cranelift instruction, function, whatever it is, the equivalent converted entity in Pliron. That's what I'm storing. So I do the conversion, I store that. I do the conversion, I store that. Yeah? Although it's already present in the context, I'm not going to access the context. I'm going to just keep this around for myself. Make sense?
Yes.
Okay.
This is more like data type, right? It's not a source element. Context is more like types.
Context
Not
is
storing anything in that.
context is your main storage area. This is like a easier what you'd call storage space. So context stores everything in a very particular format. Here, I basically have done the conversion. I don't want to only put it in the context. I also want like a copy over here so that I can quickly access it for whatever I'm doing.
So whatever the function we're getting or putting, that we're treating as a data and then we're doing operations.
Yeah, we'll get to the part. Wait. Yeah, we first get the Cranelift function over here, and then for the Cranelift function, we go ahead and create all our prerequisites. Then we call convert function. This convert function, if you see, converts a Cranelift function to a Pliron function op, translating all Cranelift entities into their Pliron equivalents and storing them in the converted entity store. Okay? So how does it work? There's another function that I've also described inside inside the main convert function. This is a separate standalone function that's here because it's, I put it inside here because I wanted to like really, this is basically layout. Okay, I didn't want,
You can have function into the function.
yeah. You can do that because I basically call that function from here. Okay. So, but let me help you with what I'm doing over here. So this function exists. But before I get to the function, see what happens here. First, I take the function name. This is the Cranelift function name. Then I get the name out of it. Then I take the signature. I take the types, the parameter types. I take them out. Then I come here. I look at. I have enough information now to create a Pliron cliff type. I have enough information because I've extracted all the information I need from the Cranelift type, from the Cranelift function. I got what? I got the name, I got the signature, I got the parameter types, including the return types. Yeah? Yes? Now once that is done, now this type is a Pliron type. I say, okay, create the type using the parameters and the return types. Then go ahead and create the actual function operation using this type information and a name for the function. The name comes from here. Okay? And then finally when that is done,
Function op is actually a opcode for creating the entire
function op is the equivalent of a Cranelift function
in Pliron world.
in the Pliron world. Yeah? So then I store a couple of things into the conversion store. Okay? Then lastly, I do a convert. Now that I actually have a function op, I do a conversion. That means I only have the function converted, but not all of its contents, like all of its the components. Like it's got a body. The body has instructions. The body is basically a basic block. It has instructions in it. All those instructions I don't have, correct? All of them I need to convert. So if you go back to the definition, you'll start to see that, okay, now we're here. Now I'm going to start going through each block. If you see here, I basically use the Cranelift function and I get the data flow graph out of it. And then I start going through the blocks. You see here. For each block, do these things. Then within each block, you have instructions. Yeah? Do the conversion. Look at the way conversion is done. Convert. So for each block, convert block. Then I come down here for each instruction, which is the Cranelift instruction. I perform the conversion of the Cranelift instruction. Right? And then I do some other checking and stuff, and this is where I do the linking part. That means which instruction is followed by which instruction. Which block is followed by which block. All that also needs to happen. That happens both. That happens both here in this section, and it also happens here. For operations or instructions, it happens here. For blocks, it happens here. Yes? Once that is done, I return. Okay? Now I have like a full function with all of its components also mapped and linked out. Converted and linked. Right?
Yeah.
So now with that context, what I do is I just say function op. So when I say convert function and then I get my function op back, it's a result. So I basically check whether it's an actual function op. And then I go ahead and display it. What did I get? Right? If I go ahead and display it, here's what I get. Let me just clear this out. So this is the test that I'm going to run. And if you see closely, just so that you guys are clear in your head.
Yeah.
Okay? That's the exact test I'm running. Okay? Now let's look at the output. So for the Cranelift function that we took in, we produced this Pliron cliff output.
Yeah.
There's some errors in there, don't worry. But for example, this is the name of the block parameter. This is your SSA value. It should be the same thing over here, where somewhere over here, it sort of needs to be the same, but it's looking different. The block value is changing. I don't know why it's changing. I need to figure that out. Second thing is, return must not have this entire thing. The printing is wrong somehow. That I will figure out. But so far, does that make sense?
Yeah.
Yeah.
So there is a like this function what is there. If you consider that is one type which is in cliff fire, that type we want to convert into
Pliron
type. So that conversion we are creating this.
Correct. So just to confirm what we're doing again, I want to show you. So far you saw only convert function. No, I have to convert not just the convert function, because when I hit convert block, I need to go up. Actually, before convert block, any Cranelift type I see. So far I've only seen signed I32. I've only implemented that. So if I see that, here's what you need to do.
This will be replaced there.
Yeah.
And how is your Pliron function? I want to know what all is there in the function. You will implemented two opcodes, right? The return, addition, and
Return, addition, and subtract at this point. Because right now, if you look at my example,
it has only those two.
it has only those two. That's why I only implement that.
Yeah, so function, addition.
I add and return. These are the only two instructions. Okay.
Yeah.
That's why I implemented only those two for testing.
Yeah.
And then if you see convert block, same thing. I'll be converting a block. Then if you see the most important thing, convert cliff instruction. Cliff instruction will produce ops. That's what this is. Same thing, operands. Okay? That's it. Make sense?
Yeah.
Like that. It's going to be a recursive thing. Like you'll keep converting till you get what you want. If you see something, I want this. You see something, I want this. No regular expressions. Okay? The context is this. Why no regular expressions is a good question. It's because when you're talking about machine instructions, etc., there's not just match and replace text. Okay, I talked about SSA values. Okay, then I'm talking about which if one instruction has side effects, if it has additional attributes, all of that is not present for you to even think about it. You need to go fetch that information, query it, and see, okay, can I do this or not? Is this valid or is this illegal? All that cannot be done with just a regular expression. Okay.
And once we get this thing, then we going to analyze this Pliron IR, and then we are going to optimize that.
First, get it into this form.
Yeah, this
Yeah.
form first.
First is this headache.
First step.
Once you finish this headache, then you do all your fancy stuff.
What is our IP?
That is where, like for example, I want to do something like aggressive inlining. You remember somebody was talking about it? Code needs to be inlined. We don't do that. Okay? We don't do things like mem to reg. That's a simple optimization, but that's not done. So all those optimizations we need to do, and then that becomes your optimized Pliron cliff, which will be translated to regular cliff.
And how easy is that? For that also we need to write parsers.
Yeah.
But it is like you have to use a brain and all that.
No, nothing like that. See, how I wrote this,
Same is for
same thing you need to do for that. You need to reverse the process.
Pliron, say
Okay, Pliron to cliff to this thing is reverse process, but the optimizing part is where you have to apply your full.
But in
The logic and all.
optimization, there are like we have to follow papers and this. Different techniques are there.
Yeah.
Yeah.
Whatever
You can get
want
as
money.
as smart as you want, as thing as you want. Okay. Personally, here's the point. We'll be able to do some of them, but as you correctly mentioned, why not really compiler PhDs over here? We're not going to be reading papers left, right, center and implementing it. We'll be trying to look at how we can achieve an objective. Okay, so we're mostly in the applied compiler engineering space, not in the the academic space. Of course, if somebody comes up and says you can do this, we probably will be the guys who will implement it. Okay, that's the job. Make sense?
Yeah.
This makes sense now? You have a clear idea where we're going with this? Tomorrow I will cover one key aspect. You saw that the second macro I talked about, which is this. So I talked about the second macro, which is, if you see this, I'll just explain this a little. You see is terminator interface. It basically tried to say that return op, after return generally, there's no other instruction. You return. So this is a terminator interface. So interfaces are basically describing the properties of your operations. Like for example, this is one, right? And then you can also see here, this is the IAD operation or the add operation. You see that this operation returns one result. This operation uses the same operands as type. If you provide operands to it, both operands must be of the same type. This operation will return the same result type. This operation, same operands and results type. This operation is a binary arithmetic operation. This operation does integer binary arithmetic operation, like the level of detail that you have to dive into.
So all is defined in this source, right?
Correct. This will be expanded. So if you actually expand this, you'll be able to see it. For example, let's look at the IAD operation. Okay. I'll just take one, so I won't take up a lot. You see, integer binary arithmetic operation is implemented for IAD. You look at the implementation, it's empty. There's a reason for that. Because if you go back to something like this and look at the operation interfaces that I've already included, this is not mine, this is already present. I've just taken the same thing because it's an add operation. I don't have to implement much. Integer binary arithmetic operation is right here. Where is it? Right here. Okay. It's a trait. In order for an operation to be an integer binary arithmetic operation, it first needs to implement binary arithmetic. Binary can be between integers, floats, whatever, binary, right? So in order for this to be an integer, first it needs to be a binary. That means it needs to only operate on two specific operands. And then in here you will be able to see only one method, verify. Now this verification part is what we'll cover tomorrow. So when you are defining your own stuff, you can say whatever the hell you want to say. You can say all crazy things because you don't really have to prove it types. That's why you have verify. Whatever you're saying, exactly what you're saying, show it. Show it. So as an example, if you see this, what are we saying over here when we call verify? We're going something called op cast. Okay, if you read cast reference to an object to an interface reference. I'll explain that in some time. But in general, what you're trying to do is, you're trying to see whether these two types that are passed in are the same type and whether they're integers. And then if that is true, see, you're also trying to check whether that is the signedness of it.
Yeah.
Okay. After that, if all those checks pass, then whatever you're saying, the instruction is correct. Right? Because what I'm trying to say is, I said that this has to be an integer, this has to be a binary operation. But I want you to describe that in code so that I can verify it if I look at it later. Get it? Because it's like XML. XML, I can write any piece of XML can be anything. Or like JSON. I can write JSON whatever I want. Any key value can mean anything. I don't care. But that's not what you want. You want to be sure that if I mean this, I mean this. It cannot be reinterpreted and stuff like that. Yes? That's why you need a verification piece as well. Okay, at least now you have a grasp over why we need the second macro. Because the first macro helps you define the operation. The second macro attaches what are called interfaces.
Scope.
Yeah, it basically attaches properties to say that, okay, your operation can do these things. And I verified that they can do these things. So if I want to quickly query whether my operation can do this, you can quickly go ahead and check it, and then you accordingly use it. Got it?
And the last one is again verifying everything, right?
Yeah, so every operation at a bare minimum will need the, so I've written notes over here, wait. See how valuable your notes are? Huh? Okay, implementation notes. What's a Pliron operation? This is what a Pliron operation looks like. Okay, this is not the context, this is the operation.
Yeah.
The operation will have an ID, it'll have a pointer to itself, it'll have results, it'll have operands, right? And then it'll have successors, which I will talk about later. Block links. This is where you'll be linking the next operation and the previous operation. That means the next instruction and the previous instruction that this will follow and succeed and proceed. And also which block is this an instruction of. That's where you'll capture this information. And then there's some attribute stuff that you want to keep around. You'll put it in the attribute dictionary. All right? All that's fine. But here's what happens. So at a bare minimum, you need to keep in mind these things. If you want to create an op in Pliron, you annotate a unit struct with this macro. Okay? You annotate a unit struct, which means return op, put the macro on top of it. I add op, put the macro on top of it, which is def op. Then you annotate. So here's one prerequisite. If you make something an op, at a bare minimum, it needs to have these three traits implemented. Printable, parsable, and verifiable.
Okay.
So you either implement it yourself or you have a macro do that for you. It depends on what you want to do. And then annotate a trait with op interface macro to turn it into a Pliron interface. That's how you add the second macro. Okay. Additionally, we can either annotate a Pliron op with whatever you just saw, which is this, or you can also put it on the implementation that I'll show you later. Just note that you can do this. You'll have to do this so that you can add more information to your operation.
I didn't get the last one. Where are we?
Which one? This one?
Yeah, additionally we are integrated with Pliron app.
So this is the same thing. Like if you go back here, so if you see this, derive op interface implementation, see that? You go back there, exactly what you have, derive op interface implementation, list of interfaces. It can be one interface or many interfaces. Does not matter. Okay, so it's something like this. You have a Pliron interface, the trait, you saw that binary stuff. Then you have an op, you put these two, you put this thing and this thing on top of it, you put def op and derive op interface implementation on top, you'll be able to get your Pliron operation. The thing I was trying to make was you can either write it this way or you can either write it this way for the second macro. Second macro, okay. All right, when an op is verified, its interfaces are also automatically verified.
Yeah.
Okay. When an op is verified, also its properties need to be verified, no? That's what it means. And that's what you have over here, verify interfaces. Okay. All right, and then parsable, printable, verify. There are some macros that Crate provides, like canonical syntax, verify success. If there are simple implementations, you can just use this. You don't need to implement it yourself. So it'll implement these three. Canonical syntax will implement parsable and printable. Verify will implement this. Depends. You might want to do custom implementations. That's what I'm thinking is the issue with this. What you saw in here. I said this is wrong, right? This should not be there.
But all the ops will be this thing only, unit structs only, right?
Yes.
So then we can use this thing for all the ops, right? These macros.
No, they unit structs, but if you want to print something very differently, your printing is going to look a little different. Your parsing is going to look a little different. Imagine every op, if you see this, for example, so if you see this, the entry block looks very different. The function thing looks very different. And then cliff add looks different, right? So you might want to have a different printer depending on what you're doing. But generally, you can just use the standard macro, canonical syntax macro, right?
Okay.
Yeah. Then, now once that is done, or you can go ahead and actually implement it like this, which is what you see.
Okay.
All right. You can either do one of those two things. It's up to you. What I'm saying is when you actually go look at implement canonical syntax, at least for return op, this is the exact implementation that happens.
With that macro.
Okay. So all Pliron interfaces provide a verify method. All of this I'll be talking about tomorrow when we go through that remaining piece that we need to look at. Got it?
Yeah.
Any questions?
It's almost clear now. Need to revise the code once.
Yes. Of utmost importance is that right now when it's fresh in your head, please sit down, clone the repo. You don't even need to write code. I want you to walk through that. Walk through Pliron Cliff, the example that I have. Just walk through it.
Yeah.
Make sense? Okay. Any other questions? Nothing else? No? That's it? Stop? All right. So that's the end of day one. Right?